Hello guys, gals, and NBs. So yeah, I've been making these disintegrating statues. It is a geometry that is converted to a point cloud, and then manipulated like a point cloud. I then convert the top back into a SOP to interpolate between the points. It's a little bit computer breaky, so I encourage you to not go crazy with too large geometries. This is not a perfectly smooth and optimized technique. If you are good with GLSL, there are probably better ways to do this. But artistically, I think it works. It teeters on that uncanny valley edge. Recognizable object, get deconstructed and disintegrated into a glitchy 3D mess. I think that mess is pretty. It sits in that nice liminal space between naturalistic and artificial. Let's get started with this. The first thing you need is a 3D model. You can find ones for free online. Just Google it. Or you can buy nicer ones. I will link to the ones I use in this tutorial in the description. Or, you could be a serious artist and make your own in Blender. Let's just take that geometry and drop it into our project. I have this David statue, because I'm classy like that. And oh, this one is huge. For this project, I want my geometry with the y-axis representing height, and to sit between 0 and 1 in height. Let's fix that with a transform SOP. Let's start by rotating it 90 degrees. And let's scale it down. You can middle mouse click to see the measurements of the geometry. We want it to sit between 0 and 1. But it doesn't have to be perfect. Let's connect this to a null and start going into top world. First we need to go through chopland. Sop to chop. And a null. And then chop to top. Let's set it to RGB, and fit to square. We're gonna need that alpha, so change the pixel format to 32-bit float red, green, blue, alpha. Let's connect it to a null called start. And a null called points. Let's view these as points. And there it is. Top to chop. Under crop, select full image. Let's delete the alpha here. And rename the channels to TX, TI, and TZ. A shuffle chop. Sequence channels by name. And a null. Chop to SOP. And a convert SOP. I like this effect as a Bezier or NURBS curve to create smooth curves, but this can be a little draining on your computer. So skip this step if you want sharp angles. Let's connect this to a geo. we need a camera. And a render top. Let's leave this output at 8-bit fixed, since we won't do too much post-processing today. And we can turn up the anti-aliasing. A null. And a transform for background. Set up your camera. Let's use a PBR as material. Turn down the metallic. We need a light. I'm using a cone light, but the light can really change things here. Set it up nicely. And since it's a PBR, we can use an environment map. Load and dry here, or you can make your own environment map with some ramps, noises, and creativity. The environment map uses an image to illuminate your material. It's really powerful to create realistic lights and materials. But you can also just use the artificial lights provided by TOUCHDESIGNER. Play around with it until it's pretty, but not too intense on your machine. So it still runs in real time. Remember to turn on shadows in your cone light if you want those dramatic shadows. Hard or soft. Okay. I'm happy for now. I want my David to stand on a floor. So let's drop down a circle SOP. Let's direct it to the Z, X plane. And a merge SOP. You can get creative here and add other geometries. I'm also adding a tube here to add some height. Just feeling it out. Don't copy me exactly here, because I'm just testing things. But here's the secret ingredient. A sprinkle SOP. Yeah, that's a pretty mess. Feel it out. Okay, let's actually get started with manipulating this. The first thing we are going to need here is a feedback top. And, as always, a keyboard in Chop to reset it. Drop down a noise top. Offset 0. Monochrome off. Amplitude 1. I'm also turning down the harmonic gain a little bit. Let's connect this to the first input and set it to noise under output. Let's also connect the feedback to the second input to get the x, y, z coordinates. Connect it to a math and multiply it by something small, like 0.003. We're going to play with it later. You can think of this as the speed of the transformation. Let's add it to the feedback loop. And remember to drag the end null to the feedback. And there we have it. We want to control this transformation. Let's do it with a threshold connected to the first input of the noise. And set the noise to input times noise, under output. Set your comparator to less, and let's select green, for height, since we want this scanning from top to bottom. Now, we can scan this noise from top to bottom using this threshold. But we want the geometry to return back home also, don't we? Let's connect a math to the start null, going over the feedback loop. Let's multiply it by something in the range of 0.2. And let's put to an over top. Now, there is also a force pulling the points back to their original position. But let's also scan that force with a threshold. Copy and paste the threshold. Connect it to the start null. Let's change the comparator to greater. And let's multiply these two. And let's make sure the overtop feeds into the noise and threshold down here. We also want these thresholds to work together, so I'm going to reference the threshold and softness values from this one to the other one. Now when we scan down and up, we have this effect. If you want, you can put down a noise before your thresholds to make it a little messy, eh? But let's look at what we can do to make it fall downwards, toward the ground. We need to add some negative green to the vectors. Let's use a constant chop. Under output, set resolution only. 0 red. 0 blue. -1 green. And add it to the noise before the math. We now have a downward force. But it just keeps falling. Let's use a limit top over here. Let's limit minimum with clamp or zigzag. Set the minimum to 0. And mask the red, blue, and alpha channel. Yeah, this is nice. Let's drive the threshold with an LFO. Let's use Gaussian. Turn down the frequency. Set the offset to something like 1.2. And the amplitude to -1.2. And drag that to the threshold. Let's also use a constant chop with a speed to drive the noises. I also think everything is falling down a little too fast. So let's link the LFO to our downward force. We can just use this value, but offset it by -1. Now, the downward force increases as the threshold moves down. It's a little more dynamic. Neat, huh? We're basically done here. Let's just make some camera movements and polish the lights. Add a null for the camera to look at. And let's use a circle SOP for the camera path. And let's drive that with a ramp LFO. Thank you everyone who suggested this in the point cloud tutorial. So yeah, the rest is just polish, you know. Thanks for watching. I'm looking forward seeing what crazy stuff you do with this. Cheers.